Okay guys, welcome, and as you can see I'm not here, but I hope that you can follow along and do what you need to do, especially 6th hour. I want to remind you of your little warning, so you need to make sure you're getting done what you need to get done. Okay, you just had a few minutes to do the measuring angles worksheets. I want you to look at this and correct your work. This first angle, what you want to remember is that this beginning ray down here is always at 0 degrees. So as you read up your protractor, notice that here it falls between 40 and 50 and between 130 and 140. So you need to use a little bit of common sense. If you're starting at 0, you want to follow these bottom numbers to see that it's going up and it's a 45-degree angle. Okay, so please check your work. The second one, obviously, if you start at 0, you go all the way around 10, 20, 30, 40, 50, 60, all the way, that would be 130 degrees. This one, notice that the beginning ray is over here on the left. And so remember, this is 0, so now you're going to be following these outside numbers around. So it goes all the way around to 165 degrees. And make sure the degree symbol, my pen's a little sloppy, it should just be an open circle up there. This one, you're at 0 and you count up. That's a 90-degree angle. And hopefully you recall from your earlier education that a 90-degree angle is called a right angle. And we can draw a little box here in the corner to represent a right angle. The next one's a little tricky because you have to kind of move your protractor, move your paper to read it straight. But always remember that your bottom edge is always at 0 degrees. So you want to be following up the numbers that start with 10, 20, 30, 40, 50, 60, 70, and then we have to use some estimation. This small line right here is 75, so we're not quite to 75, but we're more than halfway from 70. So I would think 73 degrees would be a good estimate. Okay, and then this one, spin it all the way around. If you go from 0 and you count up, that would be 125 degrees. Okay, so hopefully you did okay with that. On the back, when you measure these and you set your protractor down, you measure up, again 10, 20, 30, 40. This is 40 degrees. And we would call this an acute angle because it's less than 90. The next one, put your protractor here. Again, we start over here at 0, so 10, now we're following the bottom numbers around, and it's going to be 145 degrees. And 145 degrees is greater than 90, so we call that an obtuse angle. In this one, as you can see, it looks pretty good to be a straight corner, which is a 90-degree angle. That's a right angle. And like I said previously, we put this small box here to represent a right angle. Okay, please put this aside and hang on to it. I will be checking that when I get back. Now I'd like you to pick up this sheet of paper. Let me zoom out a little bit. And I would like you to fold it hot dog style, so that it's going to make a foldable here with these titles in the front. And eventually I will give you a sharp object to cut these, but while I'm gone I think it's best to not put sharp objects in your hands. I know you guys miss me a lot. You might want to like hurt yourselves or something. But I want you to keep in mind as you're writing that eventually we're going to cut these flaps open, so everything you write for vertical angles needs to stay in this region. Okay, so as you can look, we're going to be talking about how different angles relate to each other. So vertical angles, adjacent angles, and so forth. Hopefully some of this will be review for you. The first one we're going to talk about is vertical angles. And the definition is two angles that are formed when two lines intersect and they are opposite each other. So two angles that are formed when two lines intersect and the angles are opposite of each other. So I'm going to draw a picture of that. So we're going to do lines, and remember in math, a line is a ruler line, not a curvy line. It's unbroken and it's unbent, and it continues in both directions. So here's our two lines intersecting, and they intersect at a single point. And hopefully you can see that this created four distinct angles. Okay. Well, vertical angles, I'm just going to number these. Vertical angles are two of the angles that are directly opposite of each other. So 1 and 3 are considered vertical angles. And vertical angles are also congruent to each other. And I know that's a brand new word. Congruent means they're the exact same size. And so in geometry, when we want to show that two angles are congruent, we put a single arch here. So let's just suppose that we measured this angle over here and it was 50 degrees. The angle opposite over here would be 50 degrees. Okay. With these two lines intersecting, is there another pair of vertical angles? Well, the answer is yes. The other pair of vertical angles, let me grab a different color here, would be angle 2 and angle 4. They are opposite of each other, and they are not going to be the same measure as these two, but they're going to be congruent to each other. So in this case, we would do a notation like this. We would do a double arch to represent that this angle and this angle down here are congruent. Okay. The next one is called adjacent angles. Adjacent angles are angles that share a vertex. They share a vertex point and have a common side. There are angles that share a vertex point and have a common side. Alright, so I'm not really sure what the common side means because I'm not sure I know that angles have sides. So let's draw a picture and see if we can come up with this. So the angles have to share a vertex point. So I'm going to draw an angle. So there's one angle, and in purple here, there's our vertex point. So according to this, I need to do another angle that has the same vertex and shares a side. So this is the side that we're going to share. I'm going to draw it out here. So angle A and angle B would be considered adjacent angles. Angle A has this vertex down here and has this side. Angle B shares that side and moves on. Okay. If you want to think about adjacent, means next to. Okay. If you think about it being a neighbor, if you think about in an apartment, you know how apartments share a wall. You can be in this apartment and you share a dividing wall. So these are next to each other. Adjacent angles do not necessarily have to be the same size. They could be many different sizes. So it's just a term about the location of the angles. Okay, the next one is complementary. Complementary are angles that add up to 90 degrees. Okay. So we can have angles that add up to be 90 degrees that are connected or not connected. So I'm going to give you two examples. You might want to use I'm going to use a little bit better 10 here. So if I have two angles here, and if this one is 30 degrees and this one is 60 degrees, I would say that these two angles are complementary to each other because they add up to 90 degrees. The other idea that you'll see most often is when two angles are complementary and they are adjacent. So we're going to have a picture that looks something like this. So once again, these are adjacent angles because they share the same vertex and they share a common side. So in this case, if this was a 20-degree angle and this is a 70-degree angle, we would say that they are complementary because we know that 20 plus 70 is 90. And just by looking at that, do you notice that this whole thing, we could put a square in it because it is a 90-degree angle. Okay. All right, supplementary are angles that add up to 180. degrees. Okay, so once again, we could say that 110 degrees and 70 degrees are supplementary. Because we know that they add up to 180. We could also look at them being adjacent, and if they were adjacent, it would look something like this. 110 degrees, 70 degrees. Notice they share the same vertex right here. 110 plus 70 makes 180 degrees. Okay, we're just about done. Talk about perpendicular lines. Perpendicular lines are two lines that intersect at a 90-degree angle. Okay, two lines that intersect. So we're back to our definition of a line. A line goes forever in both directions, and it's not curvy, it's not broken, it's not bent. It's a straight line edge. So if they intersect here at 90 degrees, we would use that notation to show that they are perpendicular to each other. Okay? All right, that's all the notes for today, and I'm hoping that you were able to get through that without anybody disappearing from the room. Your assignment for homework, not too many problems, but your assignment is right here. It's found on the whiteboard. So please copy that in your planner, and hopefully you have a few minutes to get started on that, but we will go over and check that tomorrow. All right, I will see you tomorrow. Hopefully I made it through my day today. See ya.